next strategy, once students have mastered the doubles, are the near doubles or almost doubles or doubles plus or minus one. So you might have a little story, it might involve, say, birds on a wire, and there's 6 birds on the top wire and 6 birds on the bottom wire, and one more bird flies onto the bottom wire. How many are there now? And hopefully students will see, hey, I knew 6 plus 6 was 12. I put one more in. It's 13. You could also use a double-decker bus scenario or a clothesline. You could tell a little story about somebody maybe hanging 4 shirts on the top clothesline, 4 shirts on the bottom clothesline, and one of the shirts blows away. How many are left? And hopefully students would start to see, I know 4 and 4 is 8. 1 blows away. That leaves me with 7. So the symbolic or abstract recording for a near doubles fact might look something like I'm going to show you. Again, this would be done alongside modeling on the Rekenrek or as a student is explaining how they found the answer. So you could start with a fact like 5 plus 4. So students have displayed it on their Rekenrek and they figured out some strategies. And a student might say, well, I started with 5 plus 5 because that's very close to 5 plus 4. And I knew 5 plus 5 was 10. But I knew that was 1 too many because we were supposed to have 4 and not 5. So I took 1 bead out. So 10 beads subtract 1 bead equals 9. So I know 5 plus 4 equals 9. Another student might say, hey, I did that a different way. I started with 4 plus 4, which is also close to 5 plus 4. And I knew 4 plus 4 was 8, but I used 1 less than 5 plus 4, so I had to put in 1 bead. So you would show that as 8 plus 1. And the total I got is 9. So this is a great way to show students that there is more than one way to solve the same problem.